Okay, so let's look at this typical kinematics question. We have a car with an initial velocity 25 meters per second south. 10 seconds later, it has a velocity of 8 meters per second west. And it wants us to calculate the average acceleration of the car over that time. So the answer's there if you wanted to give it a go yourself first. Otherwise, we're going to jump right into this solution. So it's always a good practice to write down all your givens first. So let's do that. V1 is equal to 25 meters per second south. V2 is equal to 8.0 meters per second west. The time, delta t, is 10 seconds. And what we're being asked to find is the acceleration, or average acceleration. Okay, so we have an equation where we can directly calculate this. So acceleration is change in velocity divided by change in time. So we can break that into v2 minus v1. That is how you calculate a change in velocity. Final minus initial divided by delta t. Okay, but we have to be careful because now we're dealing with vectors. These aren't pointing the same direction. So we can't just simply do 8 minus 25 to get delta v. We need to subtract them as vectors. So let's recall here that v1 is something like this. 25 south. V2, I'm going to use a different color here. V2 is something like this. 8 west. So, if we're going to add those things as vectors, well, subtract them actually in this case. So we've got V2, which is our 8. So let's put it somewhere. That's our V2. Now, if we wanted to add them, V2 plus V1, we would go the head of V2 goes to the tail of V1 and continue. And then our resultant vector would be from our start to the end, like this. But in this case, we want to subtract. We want to do V2 minus V1. So if we're going to do V2 minus V1, we can think of that as V2. So V, just as a little aside here, V2 minus V1 is the same thing as V2 plus negative V1. And it may seem like, why am I doing that? It's just so that now we can use the same process for adding vectors. All we have to do is just flip V1 to be negative V1. And all that means is just draw it in the opposite direction. So instead of going down south, it's north. So negative V1 is simply the same vector, but pointing up. So this is now V2 plus negative V1. And the resultant vector, use a different color again here. You simply go from the start to the end. So that's the vector that we're trying to calculate. So we have, this is negative V1, and we are trying to calculate this vector, which is V2 minus V1, or delta V. So here, this is a right angle triangle. So we can calculate the length of that black vector just by doing Pythagorean theorem. So we already know that the magnitude of this one is 25, and the magnitude of this one is 8. So delta V magnitude, and maybe I will do this. The magnitude is just 25 squared plus 8 squared is the magnitude squared. That's just Pythagorean theorem. So delta V magnitude, meaning just the number, we're not worried about the direction yet, is going to be the square root of all of that, 26.2. And the units would be meter per second because it is a velocity quantity. Okay, so now we know that this whole side has a magnitude of 26.2. All right, so if we go back to our acceleration formula where we were doing the calculation here, I'm going to move it down here so we have a little more room. We can now put that number in. So we now know the magnitude of V2 minus V1 is 26.2 meters per second divided by delta T, which was 10 seconds. So we're going to get 2.6 meters per second squared. That's going to be the magnitude, but now we need to figure out the direction. So we need to figure out the direction of this black vector. In order to do that, we're going to have to find this angle so that we can say which direction that black vector is actually pointing. So in order to do that, we can just use tan. So we see that tan theta equals the opposite over the adjacent. So that's 25 over 8. So theta is just inverse tan 25 over 8. And that would give you 72 degrees if you calculate that. So that is the direction of delta V. So we could actually put that right in here. So it's west, 72 degrees north is how you would describe that direction. Start west, move 72 degrees north, and that tells you which way that black vector is pointing. So if we go back over here, our final answer is that same direction, because all we did was divide it by time. Time is a scalar, it's just a number, so it doesn't change our direction. So the average acceleration in this question is 2.6 meters per second squared, west 72 degrees north.